So next, I want to take a quick look at using some graphing technology to be able to create vector fields. So I'm on our course content page, and I'm looking at online technology resources. There's a link called Basic Vector Field, and that's the one that we're going to use to be able to plot this vector field. So in class, we looked at the vector field that had inputs in the xy plane, points, and outputs were vectors. And it was given by the formula 2x for the x component of the vector and negative 2y for the y component of the vector. The notation in this basic vector plot is that I'm using I to represent the fact that that's the first component of my vector output, and the j represents that this is the second component of my vector output. And notice that it plots the vector field automatically for me. We see the same behavior that we saw before. For positive y values, my vectors are pointing downwards. For negative y values, my vectors are pointing upwards, and it fills in all of these vectors really quickly for us. It doesn't exactly normalize the vectors, meaning that these vectors, as they have greater length, that's representing the greater length of the vector given by these inputs, but they are condensed so that they don't actually represent the length, meaning that if I think of this coordinate point as the point 1, 1, this little vector here is not actually the vector that's pointing 2 in the x direction and negative 2 in the y direction, because that would extend all the way down to here. This is something that's fun to play around with, that you can see what happens if I switch things up. Let's say that I have 2y in the x component of my function and 2x in the y component. You can have swirling behavior in vector fields. We're going to explore vector fields in greater detail in future sections of the course, but this is a great way to be able to start visualizing them.